This is 10.1, graphing square root functions. The value of a radicand in a square root function cannot be negative. That means the number inside the square root cannot be negative. The domain includes any x values for which that radicand would be greater than or equal to 0. So whatever's inside that square root must be positive. It can also be 0. So we're going to graph f of x is the square root of x. And I'm going to make a table. And I chose my x values. X cannot be negative because I can't have a negative inside the square root. So I chose perfect squares here so that I would end with whole numbers. You could choose 0, 1, 2, 3, but you will not get whole numbers as your points to graph. And that's going to be really difficult. So I made it easy on myself and chose the perfect squares. So when I plug those in, the y values I get are 0, 1, 2, and 3. Then I can plot those on my graph. 0, 0, 1, 1, 4, 2, and 9, 3. And you can see that this is a nonlinear graph, and it kind of just has a little arc to it. The domain is whatever x can be. X can be anything that is 0 or greater, and y in this case can be anything that is 0 or greater. To find the domain, you're going to take whatever expression is inside the square root, set it equal to 0, and then solve for x. In doing that, you're going to find what is the smallest value x can be, and then x can be anything larger than that as well to keep it positive. So in this case, the x was in the square root, so I did x equals 0, and x is already by itself. Then we're going to graph g of x is the square root of x plus 2 and describe the range. So make my table. Since the square root is still only of x, I am going to choose the perfect squares again. And then I'm going to add 2 to whatever those square roots are. And I get my answers of 2, 3, 4, 5, and 6. And then I can graph those as well here. And I can see that the domain is still x is 0 or greater, but the range, the whole graph shifted up 2, so the range has to be anything that is 2 or larger. Now we're going to look at a bunch of types of transformations and what do they do to the graph. So a horizontal translation shifts it left or right, and that is when we have the x minus a number. So this would be the square root of x minus 2 would go 2 to the right, and the square root of x plus 3 would go 3 to the left. When the number is with the x, it goes the opposite way of what it says to do. So minus goes to the right, plus goes to the left. A vertical translation shifts the graph up or down. This is when we have a number added or subtracted on the outside of the function. So this is square root of x plus 4. This plus 4 is not inside the radical symbol. Same thing for the minus 5, and this will shift up 4 or down 5. A reflection is where we would flip the graph over the x or y axis, and if the negative is on the inside, that will reflect in the y. If the negative is on the outside, that reflects in the x. So you can see negative inside here, negative outside. For a horizontal stretch or shrink, that is a number multiplied times x inside that function. So the square root of 3x will make it shrink. The square root of 1/3 x will make it stretch. For a vertical stretch or shrink, the number is multiplied on the outside. So this is 4 times the square root of x, or 1/2 times the square root of x. And the large numbers 1 or larger will make it stretch. Anything less than 1 will make it shrink. So we are going to identify the transformations that are happening. So I have g of x is -2 times the square root of x minus 3 minus 4. and we're saying what happens in this graph compared to the regular square root of x. So this negative 2 will make it reflect in the x-axis. The 2 on the outside will make it stretch vertically by a factor of 2. The minus 3 on the inside is a translation to the right 3 units. And the minus 4 on the end will make it translate down 4 units.